So what is remote sensing? Remote sensing is using some type of laser or satellite to collect information about an object that you know little to no information about. In remote sensing, there's actually two different types. There's passive and active. Passive detects the radiation emitted from whatever object you're trying to get information about, whereas active, you emit your own form of energy. In our case, for our project, we ended up using a line laser as our form of energy, and then that energy is reflected off of the object and then sent back to some type of computer or camera, which it interprets that information through filters and other types of software and things put in place. So for our case, we were using a line laser which emitted the laser light, which was reflected back into our camera, which interpreted it using a filter, which we called an HSV mask, set to different parameters to read the red light reflected on different surfaces to get our information that we created the final object with. So that being the prelude into the project, I just wanted to say welcome, and I hope you enjoy everything I'm going to tell you about today. This is my University of Maryland 49Y project. I call it LiDAR on the go. So our goal was to go on campus with a line laser and map a target of interest and then import it into our computer to create a 3D point cloud, which later became a mesh, and then a solid file that we then edited and 3D printed in PTC Creo 4.0. So my original object was a parking meter. However, the red line laser showed up good on my phone camera, but the Pi camera couldn't see it. It ended up black, like the picture in the middle. So I ended up changing my object to the sign you see there, which although on the front doesn't have too many defining features, on the back there are 2 or 3 posts that when you do the mesh and even the final solid part are very noticeable. And then from there, my basic setup is a 3D mount provided to us by Professor Mitchell that I ended up printing in 2 pieces. I put crazy glue and then duct taped it in the middle to keep it solid, firm, and as straight as I possibly could. And then at the top, I have my Raspberry Pi, which powers my Arduino, which controls the IMU chip that measures the angles for me, as well as my line laser. And then the readings from my Arduino and IMU chip are sent to the Raspberry Pi, which I am then able to view on my computer. So from there, I decided I wanted to map various objects in my house to test out whether my setup actually worked or not. So I tried my fan, which ended up being my final object that I ended up trying it out on, and then my polar bear sign, which unfortunately the black on it ate all the red light from the laser, so I ended up not using it. The only good returns I got was off of the white polar bear as well as the blue part. Then I also tried my vacuum cleaner, which the black pole ended up eating all of the light, and then the glass bin at the bottom that contains all the dust ended up being too reflective of a material, and then it ended up bouncing off the laser, so I also got no returns. So although my phone camera was able to see all these things, the Raspberry Pi's camera did not have a good resolution enough to see it. So for mapping my sign, you can see that there are propellers, the center part, as well as the netting, which I was hoping to capture in my 3D mesh. As you can see in my 3D point cloud in MATLAB, it actually ended up giving me good returns on the fan. So you can see the propellers, the centerpiece, a little bit of the netting. Also, if you look at just a close-up at it, you can actually see the handle at the top, and you can see that it shows a little bit of depth since it was only a front view. You can see the back of the wall distance from the front of the fan, which I was a little skeptical about because my line laser looked somewhat at an angle, but when you ended up putting the two of them side by side, you see that it's pretty much almost a mirror image. Although the 3D point image seems to be a little bit more narrow than the actual fan, which is. So from there, I decided to go out and map the actual front of my object just to make sure it worked. So when I went out to map it, I ended up getting this weird crooked shape that I wasn't too sure why it came out that way, and there was a lot of noise. I'm assuming the angle I took it at left it hitting the ground as well as the base that it's standing on, that base of sidewalk. So there was a lot of noise, which lucky for me was on the side, so I was able to filter it out. But I wanted to show the final image. And then if you look at the 20 measurements I took, which I took pretty good spacing between, you can see it still outlines the sign, but the issue I was worried about with the fan ended up showing up in that one. So here are some of the images that I ended up recording when I took those snapshots at angle 0, 2, 5, 7, 9, as well as some other ones. So you could see how I ended up getting those 20 measurements. And you can see at the top, it somewhat disappears, which explains why I ended up getting that little fading at the top on my 3D point cloud that I imported into MATLAB. So I hope to fix those issues when I went back on campus to map the entire thing, which I will show basically a quick snippet of how my recording went. So then once I got to campus, this is what it ended up looking like, which looking back, I noticed that the line laser actually is still at that weird angle it was at when I was mapping the fan. But at the time, since the front came out somewhat decent, I felt that it would be fine when I imported it. But just to show some of the features of the sign, it's just a flat sign on the front. And as I was saying, on the back, there's posts holding it up. So on the side view, I expected to see actually the two posts from the side, depending on the angle I put the object at. Then it would show the two posts on the back, as well as that base in the middle. And I was mapping it, trying to map it at least the same distance from each side. So that basically shows my expectations for how I expected it to turn out. To give a basic description of what I was doing was angling the line laser at the top of the sign to begin. Then I went over to my computer from there. After I got the perfect angle I wanted, I pulled up the code, which basically took the snapshots for me after I had set up my HSV map. And it pulls up the different angle readings from the middle column, which is the column in question, the direction I needed. And then sometimes it didn't settle out properly, so I decided to take an average of whichever one the middle one was, because it doesn't do decimal point angles, it only does exact integer values. Once I typed that into there, it would pull up a video feed of what the object looks like live, and then from there I just hit the key and it would save it, and then I would just rinse and repeat the process. So then this is just a sped up version of my mapping process, so that you could see basically the distance between each one of the angles, because I was trying to get maybe 35 to 40 measurements on each side of the laser. So as you can see, there are many moments in time where I'm very tedious and I end up adjusting it maybe 3 or 4 times before I even end up taking a measurement. And the distance between each measurement, I try to keep as close to as possible based off of the back of the sign. So the back of the sign measurement is exact because the closest I can get to it is to that yellow post. So I tried to keep all my distances about the same. I tried to record the same way every time, as well as trying to get my laser as centered with the object as I possibly could. So although I used MATLAB to do all of my measurements of the sign originally, when it came to doing all 4 sides, I didn't realize the difficulty of trying to do it in MATLAB with rotation matrices, as well as trying to shift, rotate, and do all the necessary things to create it. So I ended up using Cloud Compare, which was so much easier actually than using MATLAB, because I could easily rotate and push as I needed to manually, as opposed to entering many different codes. So after doing all of that, I ended up getting the 3D point cloud from all 4 sides meshed together as shown in the object there. As you can see on the left hand side, there are 4 text files. It's 1 from each. What I ended up needing to do later on was I ended up needing to combine it, which I'll show later. But to demonstrate what I ended up doing, I just wanted to show a bit of the editing process I did. The best way I thought to do that was to unselect two of the pieces and only leave two sides. So what I ended up doing is leaving two sides of the object, and I wanted to demonstrate how simple and easy it was for me to edit the object in Cloud Compare. So what I ended up doing was I needed to pick whichever side I wanted to edit. So I clicked on that side of it, and then I ended up going back up to the top and hitting the rotate option as needed. Then you can select whichever axis you wanted to translate back and forth, or you can just translate back and forth manually as that to try and get it to the right angle that you'd like. And then if you hold the right click, you can rotate it either up, down, left, right, or however, whichever angle you wanted it to get it just as perfect to whatever angle you want. And it gets as precise as you want it to. It reacts basically to your hand. So I ended up having to use a mouse to do the edits. And then once I ended up doing that, and I had got everything the way I wanted after looking at it from all different directions, since you're able to rotate it afterwards just by hitting the pause button, and then you can just hit play to continue to edit it. If I felt like it was good enough, I would then import the next side as needed, and then rinse and repeat the edit until I got what I wanted. And then setting up the creation of the final mesh was pretty easy. It was kind of just selecting a couple of things, like selecting about 2 or 3 things that I saw at the top. So first I'm going to select all of these, because the first thing I need to do is combine them all into one. So I'm going to click merge and hit yes, and it merges it all into one file. And then from there, I'm going to do normal, compute the normals. I'm going to go with the default that it has. Okay. And it computed the normals for me. And then I'm going to go over to plugins, and then Poisson surface reconstruction. I'm going to go with the default again. And then it gives me this shape, which is very similar to my sign. And then from there, I took the sign looking mesh and imported it as a .stl file. So what I ended up doing was saving it in the mesh software as a .stl file and importing it into PTC Creo 4.0. And then after that, I went over to the faucet on the left side, because the problem is when it imported it as a 2D mesh file, and I wanted it as 3D. So I edited the faucet and I gave it 3mm thickness. And then from there, I ended up adding a plane parallel to the X plane, and then offsetting it down to the bottom of the sign. And then I drew a rectangle on that new plane, and then I extruded it down. And then as you can see, it ended up looking pretty similar to my sign. So you can see the 2 posts on the backside, which I was hoping to capture, and as well as the flat rectangular surface on the back. Although it's at an angle, it's because my line laser actually was at an angle, but despite that, it still was able to capture it. And then you can see some globs left over from the mesh, which for some reason when you do the Poisson, it ends up making a lot of globs, which I try to edit out, which is why you see that it's a little jagged at the edges, and you can see like weird circular globs around it. But all in all, I feel like my final CAD file came out really good, and I ended up 3D printing it. So all in all, this is my 3D print. I didn't want to make it too big, because when I ended up importing it into my PTC Creo, it ended up in meters, so I changed it to millimeters and ended up this small, but oh well. All in all, the class was fun. Professor Mitchell, Will, thank you for everything. It was very hard at the beginning because it took forever to install all of the software and get it all started, but it was fun. It was nice learning the coding. It was nice doing the scans and everything, and when you see your final product, it was like amazing and astonishing to see those small little snapshots turn into this physical object. So thanks again. I had lots of fun, and keep doing what you do. Thank you.